we are going to discuss in this class, right? So let's continue with our chapter 4. Okay, for your information, all right, chapter 4 is actually the foundation of all the chapters in the book or for this course. So therefore, it is very important for you to understand the concept, okay, in order for you to continue with other chapters, right? So if you don't understand this normal distribution chapter, you are going to have difficulties for the next chapter. So make sure you listen carefully, you understand, and then for all the exercises that I'm going to assign for you, you need to do it and you need to practice, right? So remember that one of your course work that you need to do is actually the weekly assignment, where I'm going to start assigning, okay, the weekly assignment starting from this week. So I will let you know which page and what number. All right. Okay. So this is what I have mentioned in our previous lecture. So we already discussed the shape of the distribution is called as bell shape, and then the relationship between the area under the curve and the probability. As I mentioned before, also that probability, the value is between 0 and 1. When I say the probability 0, it means that it won't happen, definitely won't happen, right? If the probability is equal to 1, it means that it will definitely happen. All right. So, and then if we have the probability, okay, the probability between 0 and 1, for example, the probability 0% that event will happen. And then, so it's good if we have something, the probability is bigger, which is close to 1. So let's say the probability is 0.85. So we know that 85% that that event will happen or that situation will happen. So, for example, if you ask someone whether that someone really love you or not, if that someone say the probability of loving you is actually 0.4, I think you better leave that person on the spot. All right. So say goodbye. Come again, maybe try again, next year or next 2 years. If that person answer you that he or she loves you, 0.99%, then you should stick to that person. So, and then that person said that 1% for him or for her. So that's fair. So you better find this loyal, apa orang cakap, cowok or cewek. Alright? Okay, so and then that's a probability. Actually, we keep using it, in our daily life. It's just that we name it differently. So, in Malay we say, apa, maybe, okay, maybe, mungkin lah, okay lah, when people say, okay lah, I will go. So when that person say, okay lah, it means that the probability is 0.5. It may go or he may not go, all right? So, and then why is it called normal? Okay. So we are going to discuss it today. And then the critical value, what does it mean by the critical value? And then why normality is important in data analysis. Okay. Usually when you present your, during your Viva, when I say Viva, it means for your FYP, where you need to present to your examiners. Usually one of the favorite questions, popular questions that the examiner will ask whether your data is normal or not. All right. So that's the reason you need to understand in order for you to prepare yourself for the FYP and also for this chapter. Right. Okay, we already talked about this one. The distribution is going to be balanced, all right, left and right, because it is symmetrical right? And then the probability on the half part of it, for sure, it will be 0.5 because it is half of 1, right? But the sum, the total of the probability under the curve, it will be 0, it will be 1, okay? So, and then I also mentioned that the line, okay, the curve, the tail of the curve never touches the straight line at the bottom, where actually the line at the bottom is x is equal to 0 when we draw in a curve, in a graph, okay? So, because that's why I want to explain it to you why it never touches to 0. So, that will be our discussion today. All right. So why this curve? Okay, it shouldn't be this way. Not it's supposed not like this. Okay, but it's supposed to be just a straight line on and on. So it is infinity. Okay, we call it infinity. Okay, so why this curve is called normal? Why it can represent, our normal life? Because let's say we divide this curve, okay? As I told you before, it never touches this line, this bottom line, okay? The tail of the curve never touches. X is equal to 0, right? So let's say we divide this curve into three parts. We call it section A, section B, and also section C, all right? So why actually it present the daily or normal life of human beings, okay? Because, we can say, for example, right, this one in terms of the IQ, okay, someone's IQ, right? Those people who have a very, very low IQ, like Pak Pandey, right? Do you guys know who Pak Pandey is? Kenal tak siapa? Do you know Pak Pandey? Pak, oh, Pak Pandey. Okay. Puyi, do you know?
No, doctor.
Okay, now, okay, you need to start a research, a new research. My new assignment to those people who don't know Pak Pandey, please Google who Pak Pandey is, all right? So Pak Pandey is actually in the our apa orang kata kita punya cerita orang Melayu, right? So Pak Pandey is the one who has a very low IQ, all right? So that's why I say there are people who have IQ like Pak Pandey exist in this world, okay? So those people like Pak Pandey will be here, right? So exist in this world, but the number of those people are very, very small, right? And those people who have IQ like, Newton, uh, who else? Ibn Sina, okay, Einstein, okay, exist, but the number is very, very small, right? Not many, okay? And most of us, okay, most of the people like us, we will be in this group, okay, the middle group. So we are not that slow. Our IQ is not that low, and our IQ is not that very, very high like Einstein, Newton. Maybe some of you, yeah, you have like Einstein and Newton, but as I said, exists, but the number is very small. All right. So the same thing with wealth, okay, kekayaan, right? So people, homeless people, okay, homeless people don't have any money or property at all, exist in this world, but the number is very small. But okay, and then people who like Sultan Brunei, you know, Thailand, King of Thailand, all right, and then like Queen Elizabeth, who else? Zuckerberg, all right, and then siapa lagi yang kaya dekat dunia? Anyone? Syari. Siapa yang kaya? Syari. Okay, kalau in Malaysia, Robert Kwok, those people actually the richest people in the world. Okay, I like your answer. Uh, okay, all right. Those funny lah you all. Okay, so those people, yeah, they exist, but the number is very small. But most of us are actually middle class people. Okay, so that's why we say, if you take your respondents for your survey and also for your study, if you don't take the data, your data doesn't show, your data don't actually show balance in terms of normal distribution, it means that it's not good. So you have been biased while choosing your respondents or your subject for your study. So for example, if your data we found out that it is skewed to the right, so it means that you concentrate only those people who are good. Okay, you didn't choose actually people who are not really good. Okay, so you are focusing on good people. So it won't be very orang cakap is very beneficial to the society when you present your findings. Okay, and the same thing, if you get your data, okay, the distribution of your data, if less right skewed, so we know that you have been biased while choosing your sample, because you are choosing only those people who are not good. Okay, those who are good, only small number, right? So for example, you want to do a research on satisfaction, job satisfaction among employees in company ABC, right? So if you only choose people who have a very high salary, this group of people, for sure majority of them will show satisfaction. Usually people who don't show satisfaction, those people who are in this area, okay, in this category, because they are being discriminated, they are not get a good salary and so on. Okay, so that's why we need to choose people balance from three different categories: category 1, category 2, category 3. Okay, so that's why we call it as normal distribution. Understand? Do you understand? Atika Nabila, do you understand? Oh, Atika.
Yes, Doctor.
Faham ke tak? Ke tidur lagi? Hang kalau dok tidur, hang habakkan So, nanti saya saya bangunkan you. Okay, how about Ramla? Ramla okey ke tak?
Okey, Doktor.
Okey. Bukan Ramla memanglah sama. You bukannya orang Indonesia, you orang Sabah je kan? Ramla. Okay, so that's why I say why normality is important in data analysis, because it shows that you are not being biased while choosing your sample or your subject when doing your research or study. All right. So we don't want your data to be skewed. Okay, we want our data to be balanced. Right. So balance. So it means that because normally people in the world, they will stay in this category, okay, in the middle, not in the left or in on the right. Okay, right. So for the chapter 4, okay, people, so I would like you to write this one on page 43, right? So you have your book here. So just next to, there's a big space here, right? Big space next to the topic of the chapter. I would like you to write this one down on that page, so you know that what you need to do for this chapter 4. Okay, can you please write down? at the very top page of 43. Okay, so once you're done, please let me know by showing thumbs up or whatever. Okay, so at least I know you have finished writing uh, for this part. Okay, dah. Okay, I can see. Thank you, Anong. Okay, Saranya. Okay, okay. Idora. All right, thank you. All right. Okay, for chapter 4, let me explain what we need to do for chapter 4. If you are able to do all this, so it means chapter 4 is already in your hand. Okay, whatever the questions will be, you definitely can answer the questions, right? Remember that I'm going to assign you some of the questions at the back of the book, so for you to practice. Okay, it's going to be the same, actually, the same format for your test, right? Uh, right. Chapter 4 will be in your test, but not in your final exam, because your final exam will include more on the SPSS part. All right, the analysis using SPSS. Right. So this chapter 4, the aim is actually to find the probability under the curve, right? So you need to find the probability, right? So when I say probability, you need to write P probability of X, right? So X can be anything. It depends on the question. So you need to find what is PX. So since we already mentioned, I already mentioned that PX is actually represent area under the curve. So we need to draw the normal curve, right? So for example, you need to draw the normal curve, right? And then we need to locate the area. So usually we put this axis right here, okay? So make it as 0, right? For example, right? And then, or this center is actually to represent the mean, right? 0 or the mean. So you need to locate the area where actually the area that we want to find the keluasan, the area, or the probability. So for example, if we are asked to find the area of this part. So we need to find it out. So that's what actually chapter 4 is all about. To find the area under the curve or probability. Okay, understand? Right. So, and then before we start, we can start finding the probability. There are a few things that you need to understand, right? So the first thing is how to write the normal distribution. Remember, our chapter 4 is normal distribution. Okay, this normal distribution is actually under quantitative, all right? Continuous, right? Because the graph is continuous, right? So this one is quantitative data and continuous, right? So how can we write it, right? So we can write it with its parameter, which is the mean and also the variance, okay? So the mean is actually, we call it as mu, okay? So this is the mean, mu, okay? Kalau you tak ingat, kalau tahu brand, okay, brand Miu Miu is very popular, a very branded brand, okay? Miu actually is M, all right? So mu is the Greek letter which is means M. So the symbol is actually macam huruf M, okay? Right, and then also the next one, the parameter, when I say parameter, is actually the value belong to this normal distribution, right? The next one is the variance. Okay, this symbol right here, okay, is actually sigma, right? Sigma. right? How to draw it? Just pull this way, right? So sigma square is the variance. Therefore, the sigma is standard deviation. Remember, variance is actually the square root of the square of standard deviation. So sigma, actually S sigma, but in Greek letter they write it as this symbol, right? Which means S for standard deviation, right? So it can be written, okay, the normal distribution, we can say X. Remember, X can be any event, any question that you may have, all right? This symbol right here, okay, it looks like median, right? But we say it is distributed, okay? Ataupun in bahasa Malaysia, ditaburkan, right? So X, any event, is distributed as normal. This one is normal distribution, normal, the short form of a normal distribution, okay, with the value of mean and also variance, right? So this is what you need to say. You need to practice it. X is distributed by normal distribution with the value of its mean and also its standard deviation square. Okay, I will say this one, standard deviation. Okay, standard deviation square, right? Is everybody okay? All right, so let's practice. Okay, say it to yourself. X is distributed by normal distribution with mu standard deviation square, or mean standard deviation square, right? So you need to say it again and again and again because we are going to use this one for the rest of the semester, right? Okay, again, a normal distribution can be written as X is distributed by normal distribution with mean and sigma or standard deviation square, where mu and sigma are called as parameters. Parameters is actually the value that must be belong to any distribution, okay? The value. Right, this normal distribution needs to be converted into a standardized normal first, okay, before we can use it, okay? So a statistical normal table can only be used when all the normal distribution parameters are converted into the Z-score, right? So this is what we call it as Z-score. Alamak, what is Z-scores? Okay, very simple, right? So Z-scores is actually like, if let's say Ida, okay, for example, Ida is doing a research and Ida doing a research and the measurement of the study that she's doing is in ringgit Malaysia, for example, okay, and then let's say Zian pula, so what happened is doing a research and measure whatever he's doing in rupiah Indonesia, for example, okay. And then suddenly we have katakan we have Hasif pula, okay, is doing orang kaya minyak, okay, oil and gas punya person, okay, is doing something in gallon, right? So, for example, so this is what happened. Everybody has different measurement, okay? So it's very hard for us to compare who's good and who's bad, okay? So in order to make it standardized, everybody, it doesn't matter whether you are doing in ringgit Malaysia, in rupiah or in gallon, so everybody need to convert in something that which is called as Z-scores to make it standardized first. So everybody has the same measurement before we can find the probability, right? So that's what we call it as Z-score. Okay, how to calculate the Z-score? We are going to discuss after this, right? So for the standard normal distribution, Z values or Z scores, is actually the normal statistical table can be used because the purpose of calculating to standardize this cost, okay, or different cost like from ringgit, from rupiah, from gallon just now, okay, we need to convert it to the Z values in order to use our normal statistical table so we can find out the probability. So this is what happened. So from X, okay, remember X can be any question, any story, all right? And then you need to convert everything to Z scores, okay? X can be in ringgit Malaysia, can be in rupiah, can be in gallon, for example, right? Right? So we need to convert to the Z scores first, and then we need to use um, statistical table, which we need to draw the curve first. Remember, we need to locate where actually the area that we want to calculate, and then we need to use the normal table. Only from there we can find the probability in order to answer the question. Remember, the purpose of chapter 4 is to find the probability or the area under the curve. Okay, is everybody the one? Okay, are you guys okay? Joey, are you okay?
Yes, doctor.
Okay, great. All right. I really hope that you people can follow what I'm trying to share with you. Eh? So if you have any questions, please ask before you apa orang kata you become more confused. Right. So let's do, okay, for example, this is the Z and normal table. Remember, this is the step, the normal table that we need to use in order to find the probability, right? So it is on page 208 in your book, right? So you need to use all this, okay, this table in order to find the probability. So if you can see all these numbers right here in the table, actually to represent the probability or actually the area under the curve. Okay, so you can see this part right here. Okay, I would like you people go to page 208 now. Boleh tak pergi ke page 208? Okay. So the first thing that I want you to do, draw this straight line. Okay, this straight line for 0. So it means that this table, okay, this curve will be divided into two parts, negative part and positive, okay? This one negative and positive, right? Just like, and then you also see this part right here at the very top left of the graph, of the table. So x minus mu divided by sigma. So I would like you just add z equal, right? Right, is everybody okay? So this is actually the formula to convert from x to z, and then you need to look at this probability number, right? So in order to convert x to z, you need to use this formula, right? This formula where x minus mu divided by sigma. So I will show you in the examples after this how to convert the x to z, right? Is everybody okay? I hope so. Right. So remember, I told you just now that the center is actually to represent the mean. We know that the mean always at the center. Okay. So when it comes to the x part, all right, so we are using the mean. But this mean, remember, because we have ringgit, we have rupiah, we have gallon. So we need to change this one to Z. Okay. So once we change this one to Z, then the center is no longer the mean, okay, the mean value, but it is, we put it as 0, okay? So the center, it will be 0, right? So here will be 0, right? So just like, okay, in our graph, as I mentioned before, okay, whatever, okay, for example, sorry, I shouldn't do this. Hold on. Sat. Nanti hampa semua duk ikut. Right, so this one, okay, as I said, if it is in X, it will be, if it is in X, it will be the mean at the center. But once we convert the X to Z, all right, so the center will be 0, okay? So the center will be 0. Right, so the Z value, anything on the right side, continue. So let's do example number 1. So to make you understand better what actually we have discussed just now, right? So we have 9 questions, okay, that we need to solve. Okay, before we can solve these questions, all right? So let me ask you whether this question, is it under the X format or the Z format? What do you think? Okay. Okay, what do you think? Because remember our step, we need to have X, we need to convert to Z, and then we need to draw the curve, and then we need to look at the table, and then we need to find the probability. Okay, so in this question, example number 1, do we have the question in X or Z format? What do you think? Anyone? Alifa, apa kata anda, Alifa?
I think it is in exact format
Kenapa Alifa dia dalam Z dia cakap?
because in the it was P in the bracket Z.
Okey, anda sangat pandai pagi ini Alifa. Ini doa saya pada bulan Ramadan yang mulia ini. You are exactly correct, okay? Because when we look at the questions, it's already written here Z, not X. So people don't be pandai-pandai, don't be too clever to change it to X, all right? So because it's already in the Z format. So therefore, we don't need to do this conversion because it's already done, all right, in this question. So we need to begin from Z, we need to draw the curve, and then we need to look at the table and we are going to find the probability. Understand? Is everybody understand or not? Yeah, guys, Sunny, do you understand?
Yes, doctor.
Okay, all right. Okay, so let's do question number 1, all right? So the first one, we need to find, remember our step will be Z, okay, because we don't need to convert from X, and then we need to draw the curve, and then we need to look at the table, and then we need to find the PX, right? That's our job now. So now we have question number 1 is actually, we want to find Z is greater or equal to 1.54, right? So this is what happened. We already have the Z. So now we need to draw the curve. Where is actually the area that we are looking for, right? So the area, so remember the center will be 0 because it's already in Z, okay? So, and then we need to find the probability or the area which is, this one is positive number. Remember, just now we discussed whatever z in the positive number will be on the right side. So you just draw a line, 1.54 here on the positive side. Okay? And then, so we need to find this one, all right? The area, remember, the area, keluasan di bawah graph. So we need to find what is actually the area greater than 1.54. Based on whatever we have learned in our mathematics, okay, during our school days, whatever bigger than should be on the right side. So we need to sheet that area. So the area will be this area right here. Okay, remember this one, the tail until, okay, infinity, right? So this is actually the area that we are looking for to find the probability, okay? So how can we find the probability? We already draw the curve. Now we need to look at the table. So we go back to page 208, okay? So, and then right? So we look at here, and this table, it says that what the number, the probability number below is actually to represent any area which is on the right tail, okay? On the right tail. So if you need to find other area beside this one, let's say here, for example, you need to use your creativity, your intellectual in order to find the area. All right. So in our case, since just now we need to find PZ greater than 1.54, right? So exactly the area as we shaded just now, exactly like this one shown in the table, right? On page 288. So the area on the right tail. So what we can do, we can simply use the table, all right, without doing anything because the area is exactly at the same location. You just go to 1.4 right here, 1.4, and 1.5, and then 4. Okay? So the answer will be this one. Right? Understand? Okay, I repeat how to find this number. Since we are looking for 1.54, go to the table because the Z value, remember this is the Z value. So 1.54, right? So our answer is 0.618. Okay, so the probability of Z greater than 1.54 is actually 0.0618. Right? So that's the answer. Sangat, the senang, the mudah, right? So what does it mean by probability of 0.0116? It means that this area only represents 6.18% from the whole area. So that's what it means. But remember, your probability answer should be number between 0 and 1. If it asks to convert in percentage, then you need to convert it. Otherwise, you need to answer your question in probability number. Okay? So people, what I want you to do now, right? I would like you just to draw question number 2. I mean where the area is. Number 3, number 4, and number 5, number 6. Right? So I want you just draw the area only. Okay? Okay, once you're done, let me know. Don't worry whether you make a mistake or whatever. Don't worry, we are going to discuss them so you can correct your mistakes after this, right? Just draw it first. Okay, once you're done, let me know. Okay, is everybody okay? Nura Basira, are you here? Lim Weni, are you here, Weni? Weni, are you here?
Yes, doctor.
Okay, all right, good. Right, so have you done? Have you drawn all the graph? Okay, people, are you still doing it? Okay, thank you, Winnie. All right. Okay, so who else? Are you done?
Two more, doctor.
Okay, all right. So I give you more time, people. The most important for you to understand, okay, and to find out where the location is. Okay, I don't want to push you too much. Okay, but I can see there are a few thumbs up already. Okay, don't worry. As I said, yeah, if you make a mistake, don't worry because we are going to discuss it. All right. Okay, so let's continue, all right? So let's do the second question, the second example, right? So now we are looking for PZ, right? PZ less than 0.65, right? So let's draw where actually the location is, right? Right. So the area will be, okay, so we have a 0 here. And then again, the number is positive, so should be on the right side, 0.65. But this time, we are looking for the area less than. So it means whatever less than 0.65 should be included or should be shaded, right? So this is the area. Now we need to look at, all right, we need to look at the table. So our next step will be the table. So we go back to the table. Right. The problem here, okay. Okay, the table only give us the area which is on the right tail. So, but the problem now we have something, right? We have, okay, now I change. The problem is now we have all the area on the left side. So what we need to find out is the area on the left side, but will be based on the area given in the table. Since all of us are very, very clever people, okay, we are intellectuals, okay, we know this one is very easy. So what actually we need to do? What do you think? What do we need to do in order to find the left area based on the area given in the table? What should we do? Yes, thank you, Hasif. We need to 1 minus this area. Remember, because the total area under the curve is actually 1. So we need to find what I call this 1, this area right here, okay, minus the area, the red area here, right, which is the tail. So we need to find this area first based on the table. So we have 0.65, okay, it will be this one, right? 0.2578, right? So the area here, okay, is actually the probability 2578, right? Then in order to find the probability z less or equal to 0.65, we need to deduct, okay, 1 minus whatever the area here, right? This one, okay? So we have, okay, I bring it here, 1 minus 0.2578, right? So can somebody get me the answer? 0.74, what is the answer? Again, 512, is it? 422, 0.422, okay. Right? So your answer will be 0.65 is equal to 0.742. Okay. Right? So easy kan? As I said, if you understand the concept, it will be very, very easy. Okay. For those who already finished, check question number 2. Okay. Let's try question number 3. Let's check whether your location is same as my answer, right? So question number 3. So we need to find the area first, okay? So the area will be this one, right? So and then, but we have negative number, right? Because this one negative, so it's supposed to be on the left side, 0.95. And then we have greater than, so the area that we are looking for is this one, right? Whatever on the right side of negative 0.95. So if you realize that actually this one exactly the same as the concept is exactly the same as area question number 2. Okay, so we have this area right here, but we have the remainder of the area which we are looking for. Okay, the right side. And you need also to understand this area is actually the area under the curve is symmetrical. So whatever this one, you can even draw it like this. Same. Because if you flip over this picture right here, it will be picture number 2. If you flip over, right? So the way how to find this area will be the same. So it's just that P Z greater than 0.95, okay, which is same thing, 1 minus whatever the area on the right tail, okay. So we go to the table, okay, 0.95, okay, 95, so the area will be this one, okay. So it will be 1 minus 0.1711, right? So can somebody, all right, Kaisa, can you find me the answer, Kaisa? Okay, can you find me the answer for this one? 1 minus 0.1711. Because we shade, more than half of the area. Okay, so let's look at number 4, all right? So number 4, in order to find the area, okay, in order to find the area, so let's draw the curve first. And then we have negative number again, negative 0.72. So less than will be only this area. As I said, this one is symmetrical, is exactly like example number 1. So you don't have to minus or whatever. So this one is actually same as if we flip it over. So actually this area, okay, this area is this one, 0.72. So you can just simply get it, whatever number given by the table, it will be your answer. Okay. Gusti, can you find me the answer?
Yes, dokter. 0 to wait, dokter.
Okay.
Uh, 0, 2389.
Okay. Right. Thank you, Gusti. All right. So people, you need to understand, okay, when we read numbers after decimal point, we cannot say 2389, okay? This is just a general information. So whatever number after decimal point is supposed to read as 2389, okay? Because if the number before the decimal point, then we can say 2000 389, for example, right? So just for your information. All right. The answer should be okay. Is it wrong? Sorry. I saw some people from the chat. Ni. Is it wrong? So
Uh,
what is yeah? What is the right answer? No.
I think it's 0.2358.
0.2358. Is it like 50 or 58?
8. Yeah.
Yeah, this one.
Yes.
Okay. So how about anyone else? Do you agree with Gusti or Anu?
Yeah, 5'8", doctor.
Yeah, okay, all right, okay, good. Right, so then, okay, you already understand, okay, the concept. I would like you to try this one. Okay, first, let's draw the location. So the location will be, right, here. Okay, we have 0. And then 0.4 in the positive side. But now the area is only within these two numbers, all right? So again, right, how can you find this area? Remember the table, our table gives us the right table right here. So what are we supposed to do in order to find this area that we are looking for? Anyone? Any idea? Okay, remember this is the area given by the table, from the table, but we are looking for this area only between 0 and 0.4. Any idea what we are?
Minus with 0.5.
Okay, yeah. Okay, who just say just now? Nadia too, you see?
Ya, doktor.
Okay. Kenapa 0.5, Nadia?
Because it's half.
Yeah,
the-
it is only involve half of the graph. Remember, 0.5 here, 0.5 here, right? So that's why we need to find, okay, this area, okay, equal to 0.5 only because it involve only 0.5, half, and then minus whatever area given by the table, right? So can somebody get me what is the number from the table? Siapa? Jing Chen.
Yes.
What is the number? 0.4 from the table?
0.3446.
0.3446.
3446.
Okay, thank you, Jin Chen. Right, so can we get the final answer for this one? Who should I ask? Yeah. Let me. Sarah, yeah. Sarah. Sebab
Yes,
dulu. Yes. What is the answer? Can you find me the answer for this one?
0.1554.
554. Okay, great. Okay. Right. So I really hope everybody understand. Okay. What actually we are trying to do today is actually to find the probability under the curve, which has different area and different location. Okay. So let's take a break. Okay, for 5 minutes before we proceed to example number 6. Right. So whoever wants to go to the loo or tak bolehlah cakap drink water kan sebab puasa, majority puasa, okay, so you can have a break for 5 minutes and then we continue with example number 6, okay.